Okay, so I have it as recording. So what I wanted to do today is kind of just we're going to continue on with chapter 11 and the graphs, just so you have something to visualize. And so what I wanted to start today with was, and this is a topic that you'll see um, in your micro and macroeconomics. In accounting, you'll see that also in those types of classes too. So you'll hear this term um, more than like in a math class. You'll definitely hear it. It's also something that you guys are living. So uh, inflation, right? What is it? It's actually a derivative. And so remember, first derivative is all about rates of change, right? At very specific points. Well, that's what inflation is. It's a rate of how the prices are increasing or decreasing over a given time. So when we go back to like that implicit differentiation that we did, it was always based on time. Well, that's what inflation is it's the rate of increase in prices over a given period of time. Okay. And so what that means is your purchasing power can decline or improve depending on what's going on. And right now, I just looked it up. The rate of inflation is around, well, it depends on where you look. So that's why it's always good to see a lot of different perspectives because it can be politicized. And so I'm going to try and stay away from the politics of it. But at this point in time, and you guys are feeling this, right? You're actually feeling the rate of inflation has increased. So what that means is when you guys are out purchasing something, if you compare it to a prior year, you know that, and it can be even within the last 6 months, you know that what you're purchasing is less and less and less, or you're having to pay more and more and more for what you're purchasing. So a great example of that is you go into the grocery store. So I think I was ruined having 3 kids all in a very short amount of time. I cooked all the time. And so now that my kids are gone and, have their own families, I don't have to cook as much. And so my biggest complaint is I hate going to the grocery store. I hate it, absolutely despise it. So if I go, I usually just buy the same stuff over and over and over again. And so as you guys have experienced too, you go into the grocery store, what you bought, last year, if I go in today, it's going to cost me more. So what's cool is not that that's cool at all. It's very painful, but there is it's called the Bureau of Labor Statistics. And so I wanted to show you this because I thought this was a great little tool to have, especially for those of you going into the business world. It's always good to be able to compare because you're going to have to adjust your prices and adjust your revenue based on what's happening, with prices. So this is a tool, and I have this in the OneNote. It's and this is Bureau of Labor Statistics.gov. And so what you can do is you can put a value in here. So let's say I put in $100, right? So what this is doing is comparing the $100 that you spent in 2000 compared to what that $100 is worth now. So when you hit calculate, you can see the $100 that you spent in the year 2000 now costs you the same things, cost you $183. So you can see, yes, you really are paying more for the same thing. And so what happens is that affects the value of the dollar, right? The value of your purchasing price. Now, where this can be good is if you have, let's say you have a house, right, that you're going to sell. If things cost more, you're going to be able to sell it for more. And so inflation isn't always bad, but you have to put yourself in a situation where you can use inflation in a positive manner, right? So you can charge more for things, so you can make more money. And so that's what happened like in 2008 when the housing market crashed. People bought houses they couldn't afford. They never should have gotten those loans in the first place. And so they had to turn them back in or they went bankrupt. And so they had to turn these houses back to the bank. And so people with cash on hand, they were able to go in and pick up these houses for pennies on the dollar. And so then 3, 4, 5 years later, they're able to sell it for a raised market. And so as long as you put yourself in the right position, you can use inflation to your benefit. But if you're in the position of most Americans, it's very, very hard to make inflation work for you because we're just trying to, make it from one paycheck to the next. One thing that I wanted to show you also is you can see the further back that you go. So in 1980, I know that was a lot of years ago. In 1980, I bought my first car. And my car I bought it brand new. It was my very first brand new car that I ever bought. I had graduated from my community college. I was in a 1964 Charger. It was a muscle car. It was awesome, but it always broke down. And so I was having to go to college up in Los Angeles. And you don't want a car that breaks down all the time on those LA freeways. Even in the 80s, they were terrible. And so we decided, okay, I need to get a brand new car. So I was 20 something, 20 young. I was very young. I was like 20. I think I was 20 at the time. And I needed a co-signer. And so my stepdad had to co-sign for me and I bought this car. And you think inflation is bad now. In the 80s, my interest rate on the car. So right now, if you go and buy a car, you can get interest rates anywhere from 1%, 1.9% up to 5 or 6%, depending on your credit score. Because it was my very first car, I paid 18% on that car. That was the interest rate. So it was extremely high, and I believe in the early 80s. Housing, the interest on housing was about 14%. And so right now it's between 3 to 6%, depending again on your credit score. So it was inflation was way higher. Percentages were way higher at that point. And then you kind of work through it and you get through it. But this is what I thought was interesting. That $6,400 car today would cost me $25,000. So you can see that the buying power is way less right now. The value of our dollar is not very good right now. So part of that is just cost of goods. Part of that is what's it called? The wage, right? Right now, I think the going wage is like $8 to $10 an hour. Well, back in the 80s, I made $2.65 an hour. That was the beginning wage. So, there's lots of different things that are going to happen when it comes into inflation. It's not just one thing. It's not just the politics or who's as a president or, what's going on politically. There's a lot of other things that affect costs and inflation and all of that. So the reason why I'm bringing all this up is because today what we're going to do is we're going to talk about second derivative. So if prices is my original function, and then inflation is the rate that the prices increase, right? So that's first derivative. Second derivative is how fast the prices are increasing. So second derivative is a little bit different than first derivative. Second derivative is not slope. We're no longer talking about slope. What we are talking about with second derivative is how things are changing. How fast are they changing? Another great example is when we're talking about position. So a position of a car. So think of a position of a car. Let me get my pencil here. So we have our car, you know, starting right here. As that car moves over time, that's called miles per hour. You guys know it as speed. Same thing, right? So this is the position function. As the position changes, you get the first derivative, which is your speed. Okay, as that speed changes, right, now you gun it, right, so we go a lot faster. As that speed changes, that's called the second derivative, and that is your acceleration. Because it's how is the speed changing? So it's speeding up or it's slowing down. You slam on your brakes, your speedometer goes down real fast, right? You push hard on the accelerator, you accelerate, right? That's second derivative. Third derivative, when it comes to position, is what's called a jerk. So if you think about it, if you're accelerating, right, you're speeding up. If you change how you're accelerating, so you lurch ahead, that's called a jerk. And this is called the third derivative. So with each of these, it's how they're changing. The position changes, you get speed. The speed changes, that second derivative, you get acceleration. The acceleration changes, you get a jerk, and that's third derivative. So you guys are actually living that every time you speed up, slow down, slam on your brakes, you know, all of it. That's all derivative. And so with inflation, second derivative is how fast is the inflation increasing. So that's what's been so painful, is our inflation has increased rapidly in these last few years. All right. And so that's why we're feeling it more. It's not how it has not been a gradual change. It's been a really quick change in inflation. Okay. So that's what we're going to talk about today, is second derivative. So the process is the same. What we're looking for is different. Okay, that's the difference between first derivative and second derivative. So let's real quick go over first derivative, because these are the terms that you have to be aware of. Okay, when you're looking at first derivative, you're looking at slope, you're looking at instantaneous rate of change, okay, how things change. You are also looking at increase or decrease. You're looking at maximum or minimum. And where maximum and minimum happens is the critical points. Okay, so this is super important that you connect the first derivative with all of these points, because if I ask you, where is this function increasing or decreasing, I'm asking you to find the first derivative. If I'm asking you what's the maximum or the minimum, I'm asking you to do the first derivative. If I'm asking you what's the critical points, I'm asking you for the first derivative. Okay, so in your notes, remember, you guys can have notes for your test. In your notes, make sure you have this kind of a set of notes so that you know exactly what you're looking for and exactly what you're going to do with it. Right? That's first derivative. Second derivative is a little bit different. The process is going to be the same. Okay, so you're not going to have to learn any new math, but you have to know which word connects with which math concept. Okay, so second derivative is all about curvature. Curvature, or another term is concavity. It's how things curve. Okay, so when you look up here, these are the curvatures. You have where it curves up. Okay, that is what's considered a positive second derivative. Okay, if it curves down, that's what's known as a negative second derivative. Okay, so we're still looking at where is it positive and where is it negative, but the positive and negative now has a different definition. So with second derivative, it will curve up and then it'll curve down. All right, now if you remember, let's go back to our first derivative. Remember let me get here, our first derivative, this first function, see how the slope was increasing, it hit that critical point, and then it went to decreasing, and then it hit that critical point and went to increasing. That was first derivative. Now what we're going to do is we're going to look at where is it curving? How is it curving here? Here it's curving down. So this would be considered a negative second derivative. Here it's curving up. So this would be a positive second derivative, right? Where that curvature changes is right here. And that's what we're going to be finding. That's where that curvature goes from the curving down to curving up. Okay, so that is called, get back over here, that's called a point of inflection. Need more room. Point of inflection. And we can abbreviate it as POI. Okay, so instead of critical points goes with first derivative, points of inflection go with second derivative. So if it asks you to find the point of inflection, you're going to look for the second derivative. Okay, and it's all about the curvature. Now, how does it translate? So if you have, let's say you have a curve that goes like this. Okay, this is an increasing curve, right? So the slope is increasing, but the increasing slows down. And this is a negative second derivative. Okay, so our increasing is slowing down. So if we're talking about inflation, if inflation is increasing, okay, that's our first derivative, that's our slope. But then inflation is slowing down, that is our second derivative. So that's what this looks like is, yes, it's still increasing. You see it? It's still on an increasing slope, but it's actually slowing down. So second derivative allows us to find things that are slowing down or that's speeding up. So remember, if we're in a car and we're accelerating, we're speeding up our miles per hour. So instead of going 60 miles per hour, if I'm accelerating, now I'm at 80 miles an hour. Okay, thank you, Brian. Okay, so these are all the terms that go with second derivative. So the way a speeding up looks like, I'll show it to you this way. This is still an increasing slope, right? There's my increasing slope. But now when I come over here, you see how it's much steeper? So my increase is increasing. So my second derivative is a positive slope. So that's when I have an increasing first derivative and an increasing second derivative. Okay, now if I had a decreasing slope, okay, so here, let me put it this way. So this is my first derivative is increasing, it's positive. My second derivative is negative. That's this one right here. For this one down here where I'm speeding up, my first derivative is positive again, but my second derivative is also positive. So that's where I have it speeding up. Okay. Over here, my first derivative is negative, right? It's below 0. And the second derivative is also negative. Okay. So what that means is my decrease is speeding up. Okay, so it's still decreasing, but it's getting steeper and steeper and steeper. And then the last one is if I have a negative first derivative. Okay, here's my negative. I had to think about it. I had to think about how I'm going to draw this. So there's my negative. Let me get this. It's not going uphill. So it's a negative slope. But you can see my second derivative is positive. So my decreasing is slowing down. Okay, so it just depends on what my first derivative is doing, determines what my second derivative is doing. Okay, but the idea is we're looking for where is the intervals curving up or where are they curving down? Okay, as opposed to first derivative is where is it increasing, where is it decreasing? Okay, so this, another term is curving up or curve down. Okay, any questions so far?
So is it basically like the rate of change of the rate of change, something like that, or no?
That's exactly what it is. Yep, it's the rate of change and the rate of change, or it's how the rate of change is changing. That's literally what it is. So like going back to the position function, when you have a position and you change position, you're going at a speed, right? You're going at miles per hour. You've changed how many miles you're doing per hour. Then when you change the miles per hour, you are accelerating, right? You're going faster. I can decelerate too. So think about when you're on the freeway, you know, you see an opening, because I've been on the freeway way too many times. You San Antonio drivers are crazy. So you're on the freeway and someone comes up behind you and wants to pass you, right? So they accelerate, they increase their speed. And then in front of them, they've stopped, right? There's something going on. Another construction site. Oh, no wonder people in San Antonio drive mad all the time. There's so much construction. Another construction site. So that person that just sped up now has to slam on their brakes. So they're decelerating. So their speed went from increasing, acceleration, and then they had to slow down, deceleration. So that's second derivative because they sped up their speed and then they slowed their speed down. Okay, so it's the change in your increase. So that's why it's a speeding up or slowing down. Okay, so let's try this. So again, don't think of it in terms of steps. Think of it in terms of a smooth process. Why are you doing what you're doing? That's going to be the most important part. Why are you doing what you're doing? So for this one, this is the same one that we did on Tuesday, okay? But this one, now we're looking for our inflection points. So inflection points means second derivative. So you don't even have to worry about the first derivative. We've already done that. You don't have to walk through that process. So what we're going to do is we're going to go from the first derivative, because you can't just go straight from the regular original function to second derivative. You have to walk through the process. Okay, there's our first derivative. Not working with first derivative because I'm looking for inflection points. So I'm looking for the second derivative. So 2 times 3 is 6. 2 minus 1 is 1. Derivative of 6x is just 6. Okay. So now we found the second derivative. Then step 2, we're going to set the second derivative to 0 and solve. So exact same thing. Remember, first derivative, we set it to 0 and then we solved. Second derivative, we're going to set it to 0 and then we're going to solve. And I'm going to factor out. So my x value is going to equal -1. And the way I got that is I set x plus 1 equal to 0, subtract 1 on both sides, so I get x equals -1. Okay? So what I just found is what's called the possible points of inflection. We don't know if it's a point of inflection or not. We have to find whether it's a point of inflection or not. Okay, so next thing is we set up a test chart. So this should all look super familiar to you, like, oh, last time we set it to 0 and we solved for x and we found critical points. Oh, now we're going to find a test chart. So the difference is, but now we're looking at the second derivative. Okay, so the second derivative, again, is all about curvature. So when you find your curves, when you find whether your second derivative is positive or negative, instead of the arrows, you're going to use curves. And that will help differentiate between first derivative and second derivative. Okay, so we're going to find second derivative. We're looking for this interval, anything less than -1. So I'll plug in -5 just because it's a random number, but it is in that interval less than -1. So again, I come over to here and I'm going to do positives, negatives. My 6 is positive. When I plug in -5 into here, -5 plus 1 is negative. So that makes that whole interval negative. So I know that this side is going to be a negative second derivative. In other words, it's curving down. Okay. So now I'm going to test the other side. A number greater than -1, a great number is 0. 0 is always a good choice if you can use it. Okay, so here we go. 6 is positive again. 0 plus 1 is positive. So that makes that interval positive. So on this side, I have a curving up in my second derivative. Okay, so it literally is the exact same process. You set your derivative to 0, you solve for your x, you do your test chart, you see whether it's increasing or decreasing, and because it's opposite on either side of my possible point of inflection, then my POI is at -1. In other words, my point of inflection is at -1. So then we got to find, all right, where is it exactly on my graph? So we go back to our original function and we plug in -1. So we have -1 cubed plus 3 times -1 squared minus 9 times -1 minus 11. So -1 cubed is -1. 3 times 1 is 3. -9 times -1 is +9 minus 11. So we end up with 0. So my point of inflection is at -1, 0. Any questions so far? Okay, so now let me take you back to our graph, the graph that we did on this exact same thing. Did you remember I said right here in this box is going to be, somewhere in here is going to be where the point of inflection is. What is a point of inflection? A point of inflection is where the curvature changes. right? Where it goes from positive to negative. So because my graph is so beautiful, I'm going to redo it here. It went up, oops. Color. Okay, it went up, hit my max, curve down, hit my y-intercept, and curves back up again. So right here, that -1, 0, that is my point of inflection. And that's where the curvature changes. Okay, that's where everything changed. So it can only happen at those possible points of inflection. So it curves, or it switched curving right here. It went from a downward curve and then it started with the upward curve. And that's your point of inflection. Okay. All right. So again, the steps are find it when you're looking for inflection points, find the second derivative, set it to 0, find your possible points of inflection, draw a test chart, and then you're going to test to see what your intervals are doing. And then you're going to find out where exactly it is on your graph by plugging it back into the original. Okay. All right. So let's try one more, and then we're going to put it all together. We're going to do first and second all together. Okay. All right, here we go. First things first, I want inflection points. So I know I am looking for my second derivative. So I'm going to find the first derivative first. And then I'm going to jump right to the second derivative. Okay. And you notice I'm just using that power rule again. First derivative, original to first derivative, drop the 4 to the front, subtract 1, drop the 3 to the front and multiply, subtract 1. So that's why I got my 4x cubed plus 12x squared. And then I'm going to do it again. 3 times 4 is 12. And then I'm subtracting 1 off the 3. And then 2 times 12 is 24. And then I'm subtracting 1 off the 2. Okay. Now I'm going to set my second derivative to 0. And then I'm going to solve. So this one, I have a common factor of 12 and x. So I'm going to factor out a 12x. What I have left is x plus 2. Okay, so my two x values are 0 and -2. And where I found those is I went 12x equals 0, and I went x plus 2 equals 0. So divide by 12, and I get x equals 0, which makes sense, right? If 12x equals 0, the only thing x can be is 0. It has to be 0, because 12 times 0 is 0. That's the only way to get 0. And then on the x plus 2, I'm going to subtract 2 from both sides. So I get x minus 2. So hopefully you're starting to see this quicker, where you don't even have to do this part. This part is just extra. You should be able to just see it. It's always going to be the opposite sign of what your binomial is. Right? All right, so these are our possible points of inflection. Now I'm going to do my test chart, and this is second derivative. And make sure you put these in order. I had a student just yesterday do 0, -2, and she couldn't understand why it was messing up, why it wasn't working. So it's got to be just like a number line, right? The negatives have to be over here, positives have to be over here. Okay. All right, I'm going to get rid of this so we don't need it. All right, so now let's test our intervals. So less than -2, -5, and again, you can use whatever you want. So 12 times -5 is negative. Did you notice I didn't care what it was as far as what the value was? All I care about is if it's positive or negative. And then -5 plus 2 is also negative. So a negative times a negative makes that whole thing positive. So I know it is curving up. So with the second derivative, it really does help to not do arrows, because remember, arrows is first derivative. So keeping those two things separate will really help as far as the picture goes. Okay. And then a value between -2 and 0 will go -1. So 12 times -1 is negative. -1 plus 2 is positive. So that makes that whole thing negative. And then this interval, anything larger than 0. So we'll go 1. So 12 times 1 is positive. 1 plus 2 is positive. So it makes the whole thing positive. And what you'll find is it doesn't matter what value you use in this interval, you will always end up with the same sign. So all that means is from 0 on, it's going to always be positive until infinity. Okay, between -2 and 0, that whole area is going to be curving down. Okay, now if you look at this, you go, okay, we got a up, down, up. So we know that points of inflection are at -2 and at 0. We do know that because it's opposite on either side. We can also kind of see the shape, right? If you kind of imagine what's happening here, right? It's going up and then down and then up again. Okay, so we can kind of see what's happening. Also, we know because we have x to the 4th that it's going to look something like this. That just kind of, it's just that background giving characteristic to our graph, even though we don't have to graph this one. All we're looking for is inflection points. Okay, so we know these definitely are inflection points. So now we go back to the original to find where exactly does that inflection point sit. So the second one should be easy, right? 0, 0, 15. So it sits at 15. So at 0 and 15. And then the -2. So -2 to the 4th is a positive 16. -2 cubed is a -8 times 4. So that's a -32 plus 15. So we have 15 and 16 is 31 minus 32. So this is a -1. So those are our points of inflection. So that's where the curvature changes. Okay. All right. Any questions? Well, here, let me ask you this. Are you okay with what I do here? Does that make sense to you guys? Give me a thumbs up if it does, or thumbs down if it doesn't. We have a few thumbs up. Okay. Okay, good. All right. Very good. Okay. Sometimes I need to know that what I'm saying is making sense to you, because I obviously talk fast. I actually, in my 1324 yesterday, I did an experiment because it's a 3 o'clock class, and to be honest, during the summer, 3 o'clock is like my nap time. That's when I get really tired. So I usually have a cup of coffee. I've been drinking energy drinks. And so and the healthy ones, not the Monster or whatever those other nasty ones are. But I didn't drink one yesterday and it went so much better because I think what happens is I drink an energy drink and then I talk way too fast. I just get going and just go. And so anyway, it was kind of funny. Okay, here we go. So what we're going to do is we're going to use, oh, I know what I need. No, we're all right. I can show it to you on this next one. Okay, so what we're going to do is we're going to put it all together. Okay, we've already done the work on this one, but we're just going to walk through the process so you can see, all right, I got to do all the steps. So we're going to do first derivative and second derivative all on one problem, and then we're going to graph it based on the information. Also in MyMathLab, it asks you where, on what interval does it increase, what interval does it decrease. So after this one, I'll show you, I'll walk you through a problem on MyMathLab to show you that. And it's all based on your test chart. All right, so here we go. We're going to find critical points. So that is first derivative. Okay, so we find our first derivative, which is 3x squared plus 6x minus 9. You guys, this should all look familiar to you. Then we're going to set this to 0 because we just did this one on Monday. We're going to factor it. And so what do you multiply to get -3, add to get +2? So it's got to be 3 and -1. So our factored form is x plus 3, x minus 1, which means our critical points are at -3 and +1. Okay. So now we are going to set up our test chart. And this is for our first derivative. Okay, so we're going to test in this interval. So we'll say -5. So 3 is positive. -5 plus 3 is negative. -5 minus 1 is negative. So that makes that whole thing positive. So this goes up. And then I'm going to test in this interval. So between a negative and a positive is 0. So we like that. So our 3 is positive. 0 plus 3 is positive. 0 minus 1 is negative. So that makes that whole thing negative. So notice I'm doing arrows on my first derivative because I'm looking at the slope. And then this interval will go, I don't know, +5. So 3 is positive. 5 plus 3 is positive. 5 minus 1 is positive. So it makes that whole thing positive. Okay. So now we know that we do have a maximum here and a minimum here. Okay, so we are going to find exactly where on my graph my maximum and my minimum happens. So with this one, we go back to our original function. And we did all this on Tuesday. Move over a little more. And I believe this ended up being 16. -27 plus 27 minus, or plus 27 minus 11. Yeah, 16. And then we're going to do the same thing for 1. And this 1, 3 is 4, minus 9 is -5, minus 11 is -16. Okay, so my maximum is at -3, 16, and my minimum is at 1, -16. Okay, now in your MyMathLab, it's going to ask you where is it increasing, where is it decreasing? Okay, so it is increasing on the intervals. So this is where you just look at your test chart. It's increasing on the intervals from -infinity to -3, doesn't include -3, and from 1 to infinity. Okay, that's where it's going up. And then it's decreasing on the interval -3 to 1. Okay, so you just look at your arrows and it'll tell you where it's increasing or where it's decreasing. And we have a maximum at -3, 16 and a minimum at 1, -16. All right. Also notice I did all of my first derivative first. Okay, I'm not bouncing back and forth. So I have -3, oops, -3, 16, that's my max. And my minimum is at 1, -16. And again, it's a sketch, right? So it doesn't have to be perfect. I'm just getting my max and my min. Okay, so now I'm done with first derivative. Now I'm going to jump to second derivative. Okay, so I remember my first derivative was 3x squared plus 6x minus 9, right? Did I say that? Yeah. Okay, so now I'm going to find my second derivative, which again, we just did this one. I'm going to set my second derivative to 0. And then I get my possible points of inflection. Okay, now I'm going to do my test chart. And again, make sure you note it, you make the notation that it is for the second derivative. Okay, so second derivative, the interval less than -1, say -5. So +6 is positive. -5 plus 1 is negative, which makes the whole thing negative. And then I'm going to test the other side. Zeros in this interval. So +6 is positive. 0 plus 1 is positive. So that makes that whole thing positive. Okay. So this is a point of inflection at -1. And then we remember what it was, but I'll go ahead and do it. So we had -1 cubed. I forgot it. Forgot the original. 3x squared, okay. Plus 3 times -1 squared, minus 9 times -1, minus 11, and all of that goes to 0. So we know our point of inflection is at -1, 0. So we just add that into our graph. Here's our POI, and now we can graph it. So we go, we increase, hit our max, curves down, hits our point of inflection, hits our minimum, curves up, and there's our graph. Okay, and then the other part in MyMathLab using your test chart is where is your graph curving up and where is it curving down? So for this one, it curves up from -1 to infinity, and it curves down from negative infinity to -1. So you just look at your graph. And that's why the test chart is so important, because you are going to have to look at that and go, okay, where is it curving up? Where is it curving down? And then where is it increasing and where is it decreasing? Okay. So any questions? And that's it all put together. So we have it all in one step. Yeah, go ahead.
On the so when you do the -5 as x, do you put that in the first derivative or
The second derivative? Yeah. And that's why I mark what I'm looking at. Because if I'm looking at second derivative, I'm looking at where is it curving. So I put it back into here. So the 6 is positive. Then I go -5 plus 1. That's where this negative came in. And so a positive times a negative makes it negative.
6 positive? So you do it in the 6 outside the parentheses of the x plus 1?
So the 6 is positive. That's where this one comes from. And then the negative, because I plug -5 in here, so that -5 represents the x. So the -5 is here. So -5 plus 1 is a negative. That's where this one came from.
Oh, okay.
Okay. And it's the same concept as what I did here, right? Except for here, I did my first derivative, which is right here.
I got you.
Okay. So it's the same concept. Okay, so what I wanted to do real quick is go through just one of the problems in MyMathLab so you can see kind of how it all comes together. I never have enough room though. Okay, so this one, just looking for, it's a little bit hard to see, but there's 2 tick marks. So 2 tick marks means second derivative, so that's what you're looking for. Second derivative. Okay, so this one says, where is it concave up, concave down? That one concave up, concave down. So where is it curving? So concave and curving means the same thing. Okay, so like on this one, what you're going to do then is, because you're looking for concavity and inflection points, you know you have to do second derivative. All right, so that's why I wanted to make sure that you have the connection between what is first derivative and the terms that go with it, and what is second derivative and the terms that go with it. So if we're looking for inflection points, I have to find my first derivative. So I get -4x cubed plus 28 times 3 is 84. X squared minus 28, that's first derivative. But because I'm looking for inflection points, I'm going to find the second derivative. So -12x squared, and then plus 168. Oops. Plus 168. Do I have the right ones? Yeah, x squared. And then the 28 drops. So this is x, not x squared. Because -4 times 3 is -12, and then I subtract off 1. And then 2 times 84 is 168, and then subtract off 1. So now I'm going to factor. So the second derivative factored, when I set it to 0, right? You're going to set it to 0. Is I'm going to factor out a -12 x. And I always use, if there's a negative in the front, I just use it. It just makes it so I don't have to deal with it inside the parenthesis. So when I divide -12x squared by -12, I get just x. When I divide 168x by negative 12, I get negative 14. So my possible POIs, points of inflection, are at 0 and 14. Okay, so again, with MyMathLab, it doesn't tell you set your second derivative to 0 and find your points of inflection and then set up the test chart. That's all stuff that you have to know how to do. And that's why I would lead you through the process with those steps. Okay, because we are looking what intervals are concave up and down. Well, I don't know until I set up my test chart. So I'm going to set up my test chart. And again, I'm looking for at the second derivative. And I have 0 and 14 are my two possibilities. Okay. So now I start testing. So I'm looking at this interval. So I'm going to look at, say, -1. So this is where I plug it into here to get positive or negative. So -12 times -1 is positive. -1 minus 14 is negative. So that makes this whole thing negative. So this side is negative. Now I'm going to test between 0 and 14. So say +1. So -12 times +1 is a negative. And then +1 minus 14 is also negative. So that makes this positive. So I do have, there's one of my points of inflection. And then anything over 14, I can use 20. Any value, doesn't matter. -12 times 20, don't care that that's -240. All I care about is it's negative. A negative times a positive is a negative. And then 20 minus 14 is going to be positive, so that makes that one negative. So I do have points of inflection. So my points of inflection are at 0 and 14. So get rid of this here. So my intervals, so at what interval of x is the graph concave up? Okay, so again, until I put my cursor in there, the little icons at the bottom don't show up, or I can just type it in. So it is concave up from negative, there's my infinity sign. Nope, it's wrong. It's concave up from 0 to 14. Okay, and again, I'm leaving my test chart here. You're gonna have to do it on paper, obviously, but leave it there because you're gonna need it. Now it says on what interval is the graph concave down. So this one is concave down from -infinity to 0, and then comma to separate your answers, and then from 14 to positive infinity. So that's where it's down. It's going down on all the values below 0 and all the values above 14. Okay, and then it says, determine the x coordinates of the inflection points. So this is a little bit different than what we've been doing, because before we wanted to know the exact value, like where it sits on the graph. All they're asking for is the x values. So sometimes they're going to ask for x values, sometimes they're going to ask for both, like where it sits on the graph. So you just have to be real careful about how you answer the question. Okay. Oops. All right, so, and also I'm sure you guys have noticed there's different parts, right? So you can look to see, okay, how many parts to the question. But once you get that smooth flow of the process, then it kind of starts compacting itself, so you can get through them fairly quickly. All right, so any questions on this type of question? All right, let me erase this. Okay, so this you guys are used to seeing. So if you need to, you can put arrows in, right? First derivative is arrows. So if that helps you be able to identify, so this is increase, decrease, decrease. So all you have is a maximum right here. And then this is second derivative. So this is a decreasing curve, an increasing curve, and a decreasing curve. So these are your points of inflection. Okay, so doing it this way instead of the plus and minus gives you a picture of what your graph looks like. Okay, so now you can see on A, let me show it to you bigger. So on A, move it over. Oh, it won't let me move it over. Okay, so we can see it with this test chart here. So on A, do you see how your first interval goes up? And this is going down. So you know A's out. A is not one of them. Here on B, we are increasing, so we're good there. It curves down and we're decreasing, right? And then, but here, do you see how it curves up again and then down? But our curvature is up or up and then down, but the slope is down, down. So this could be a possibility. It's increasing slope, curving down, decreasing slope, curves up, curves down. But then do you see how it curves up again and then down again? We only have an up and then a down. So this one, B, it looks like there's too much going on. D, we can knock out again because we have a decreasing slope here, right here, instead of an increasing slope. So it's got to be C. And you can look at it. There's your increasing slope, it curves down. There's your decreasing slope, it curves up. And then your decreasing slope again, and it curves down. Okay, so C, it has to be C. So that's why the test chart really helps. And looking at it in terms of arrows and then curvature really brings the picture instead of just guessing what it is. You can actually see the picture. Okay, and then this one is, there's 11 parts to it, so don't panic. It just makes you go through the process. The good news is it's already factored for you. You already have it factored. So this x squared minus 8x minus 32, you'll have to factor that, but it's already got started for you. So you're good to go on that one. Okay. All right, and then the last thing. Oh, hang on. The last thing is if we do, I don't think we need to do one like this, but let me just show you real quick. So this one, if you're doing a sketch, remember x to the fourth is going to look something like this. Right now, it could do like this, right? Or it could do like this. But just know that because this first term is positive, your end behavior, the two ends are going to both be up. You'll have some curvature in between, right? You'll have some little curves in between, but the two end behaviors are going to be up. And then on this one, because of x cubed and it's positive, it's going to end on a positive note. So it's going to look something like that. So you have an idea of what it looks like. Okay. All right. So I'm going to stop there. Any other questions that you have? Okay, on this one, just make sure these are due Monday, the 25th. And then we get into the word problems. So really make sure that you understand what it is you're looking for when you're doing these. And then once we get into the word problems, it'll all make more sense. Okay? That's all I got for today, guys. I hope you have a great weekend.
Thank you, ma'am. You too.
Okay.